Hello, my name is James Geiger, and I'm an application scientist with PerkinElmer, and I'm going to show how we are going to get the most out of our Labchip reviewer software today, and hopefully this will help you streamline all of your data analysis moving forward. Let's begin by going to where we can actually get the software. The latest version can be found at this webpage. Now, something that's awesome about the Labchip is that there's no licensing agreement or limitation on how many times we can download the software. So everybody on your team can have a copy on their own PC. Now that we have the software downloaded, let's load a data file. In the software, we will click File, then Import Data File. To select the data, we simply click on the wells that we want to observe. We can also select the entire plate here. The electropherogram can be seen near the top of the screen. Here we have a fluorescence on the y-axis and time on the x-axis. Let's look at one of our ladders to familiarize ourselves with the different types of peaks we may see on our data. First, we can see our lower marker. This lower marker is a 1 kilodalton peptide that we load onto the chip and should be present in every sample. Normally this comes out at about 13 seconds. The lower marker is used to align all samples to the same reference point. Secondly, we can see system peaks. The system peaks arise when we burst SDS micelles at our destaining channels. They are difficult to predict the shape and intensity of, and for the most part, little thought needs to be put into them. They normally come out in the 15 to 18 second range and are under the minimum quantification size for each assay, so they shouldn't affect our data in any way. Next, we see our ladder peaks, labeled L. These peaks will be used for determining the size and concentration of our proteins of interest. We can adjust the electropherogram by clicking the Properties tab on the right side of the screen. Here, we can label the data by type, size, concentration, or percent purity. We can ask the software to show our peak baselines, and thus the area of integration for each peak. And lastly, we can change the x-axis of our graph from time to size in kilodaltons. And we can also play with the fonts and overall aesthetics of our electropherogram. On the bottom of the screen, we see a gel representation of the electropherogram. Like the data above, we can control how this looks by clicking the Properties tab on the right. Here, we can adjust the size of the lanes, the contrast of the gel, and make any color scheme that we may like. We also have tabular data, such as our peak and well tables, that give information about each peak found in the data. These tables can be customized by right-clicking at the top of the table and selecting the parameters that we care most about. Finally, these tables can be exported as CSV files to be used however we please. It's likely that at some point we may want to change the analysis settings of the software to fit our own data and experimentation. To do so, we can click the Analysis tab on the top left of the screen. This will open a menu with numerous options for us to edit. During runs on the GX2 Touch, the system will run a ladder every 12 samples. This brackets the data with standards and allows for robust quantitation throughout an entire plate. In the Alignment tab, we can see which ladders are used for each row of samples, and we can change this if there is ever a need. The Analysis tab provides information like the size of the peaks in the ladder and the concentration of the ladder. In this tab, we can edit the dilution ratio of the ladder and sample if we have changed the protocol for sample preparation. For example, in the protocols described in most of our assays, the samples are diluted nearly 20x, hence the dilution factor here. If we change the sample preparation for any reason, we would want to change this dilution factor here to match our new protocol. Otherwise, the concentrations given by the software will be off by some factor. Obviously, we recommend sticking with our protocols. Next, we can see system peak exclusion. This tells the software the time frame to label anything as a system peak. The minimum sample size gives the smallest size in kilodalton that a peak will be labeled as a sample and not a system peak. For samples on the smaller end of what is supported by each assay, playing with this may be helpful if we think the software is labeling one of our peaks as a system peak. In the Peak Find tab, we can adjust the parameters such as height, width, slope for what will be labeled as a peak in our electropherograms. In this tab, we can also play with how the baseline is generated for the data. We can tell the software to look for specific peaks that we expect in our sample. In the Expected Proteins tab, we can program the size, window, and name of the protein of interest. These peaks will be highlighted in the data if selected. Also, we can append any parameters that we are interested in directly into the well table for quick reference. Similarly, we can exclude certain peaks. Or, if we wanted to perform an analysis on a smear or a particular size range, we can do that as well. The Titer tab allows us to program in specific wells that we have placed our own standards in. If selected, this will make the software calculate the concentration of our samples based on these wells instead of the latter provided in our reagent kit. If we loaded replicates into the plate, we can program them into the software under the Replicates tab by selecting the wells and hitting Add. Quick statistics can then be calculated by printing a replicate report, which we will see in a bit. The most important thing in the Advanced tab is the peak integration mode. Here, we can change how our peaks are integrated from the baseline or from valley to valley. Also, these integration baselines can easily be changed manually. Peaks can be merged by right-clicking on the electropherogram and selecting Merge Peaks. Holding Control and dragging over the peaks lets the software merge any peaks that are selected. In the same way, we can split peaks using the same protocol. Any changes that we've made to the analysis settings can be saved by clicking the Export Assay button found here. This file with the saved analysis settings can be saved to the assay folder on the GX2 Touch and run on the instrument. After the run, the software will automatically apply these settings to the data. Sometimes, when we are running full plates, it can be difficult to make sense of our data when all we see is wells A1, A2, A3 in our samples. Using the Sample Names editor can help us here. If we click on Tools in the upper left, we can open the editor. Here, we can see the wells that were run and name them accordingly. Additionally, we can put a user comment or expected peaks into this file as well. On the bottom left of this tab, we can see the Export option. This will export a sample names file as a CSV. Files in this format can be loaded into the GX2 Touch before a run is started, and the samples will automatically be named as the run is performed to save time during our analysis. During high throughput runs, we may be looking for specific metrics in our data. Perhaps that is the presence of a certain peak in the samples, or it could be a concentration or percent purity that is needed to be attained. By setting up a filter, we can find the wells in our samples that meet these criteria without having to click through our entire plate. Let's set up some filters on this data to see what we're talking about. We will go to the Filters tab on the bottom of the screen next to the gel and tables. Let's select a filter for a peak at 80 kilodaltons. Notice that I can choose the wells that the filter will apply to as well. Once the filter is added, the wells that contain a peak at 80 kilodaltons show in the color associated with the filter. Now, let's add another filter for percent purity over 80%. When I apply more than one filter, I need to pay attention to the logic that the filters are running. Here on the left, if I select OR, we are looking for wells that fulfill any of the filters. Wells that are color-coded by the filter that they fulfill, or a mixtures of the color if they fulfill both. Notice that if I choose AND, none of my filters have been highlighted in a well. This is because none of my wells have both an 80 kilodalton peptide and a peak that has over 80% purity. So we've done a lot of work to this data. If we were going to run samples in the future, and I wanted to do the same type of highlighting of the data in the future, I can save this as a template. To do this, I'll click on the collection on the top left tab and select Save as Template. Now, when a new plate is opened in the software, I can apply this template from the same tab, and the filters and expected peaks are automatically applied. This can be great help in streamlining our workflow. Finally, we have done all of our analysis and we want to export some data. To do so, we will move to the File tab and select Export. This opens a menu where we can export everything. Peak and well tables, as well as the raw data, can be exported in CSV files. The raw data can also be exported in AIA format if necessary. Electropherograms can be exported into image files, either in an entire collection or just the selected wells. Overlaid electropherograms can also be exported here. The gel images can be exported either as separate files, one lane per image, or as a single file with multiple lanes per image. At the bottom of the tab, we can select the file format of the images that we would like to export. One last thing to highlight is the ability to print a replicate report. Under the File tab, we select Print, and we can get a PDF with a replicate report. We will name the report and select the parameter that we want to compare between the replicates. If we select Print Preview, the software automatically gives you the mean, standard deviation, and percent CV on your replicates. Thank you for using the Labchip GXII Touch and taking part in this training. Hopefully, this will allow you to streamline your data analysis and boost the throughput of your lab.